Hello, welcome back. This is science class. We're going to be talking about mixtures. This is day 2 of mixtures, okay? So the materials you need are your textbook pages, the scanned textbook pages that I sent through email, as well as your workbook scanned page. This video will probably be divided into 2 parts. So for this video, I will be talking to you through this PowerPoint, give you some examples of delicious mixtures and not so delicious mixtures. And then we will be reading the textbook pages, okay? And then the second video, we'll be looking through the workbook together. Awesome. So we're going to start with a little game. So get a piece of paper or a sticky note, anything you can write on, and a pencil. So I'm going to be asking you some review questions, and each question has a specific number of points. If you get the question correctly, write down the number of points you got, okay? Once the game is over, you're going to add up all of your points, and then depending on the number of points you received, you will receive special prizes! Yay! Also, if you get a question wrong, that's okay. There's no minus points, just move on to the next question. All right, ready? If you want to pause this and review yesterday's lesson, you can totally do that, but I'm gonna get started. All right, question number 1. 5-point question, 5 points. What is a mixture? You can pause this. The answer is, ready? A mixture is any two or more substances that are mixed together or combined together physically. Okay, so if you got that correctly, if you wrote something or if you said something that's close to that, that is 5 points for you. So if you got it correctly, write down plus 5 points. So again, we have an example of mixture right here. These are jelly beans. And this is a mixture because we can take out each different type of jelly bean, right? Each of these jelly beans have their own flavor, smell, color, all that stuff. Question number 2, it's going to get a little harder. This one is 10 points. 10 points. Give me 2 examples of mixtures that we can see in real life. Pause this video. So we have a lot of options for this answer. I'm going to give you some examples that I thought of, and of course, there are answers that I didn't think of. So use your best judgment, okay? So some examples we have: tteokbokki, rappogi, vegetable soup, fruit mix, trail mix, jelly bean mix, oil and water, spaghetti and meatballs, cereal and milk, Miss Oak's getting hungry, salad, sand. Again, if you said any of these examples, or if you said something else it's not on this PowerPoint and you know for sure that it is a mixture, 100% sure, then yes, that is 10 points for you. So write down your number of points. All right, question number 3. This is a long question, but it's a very, very, very short answer, okay? Strawberries and ice cream mixing together to create strawberry milkshake is an example of something that went through a blank change. What kind of change did the strawberries and the ice cream go through to create the milkshake? 5 points. 5 seconds. 4, 3, 2, 1. The answer is physical change, okay? Because still got the strawberries, still got the ice cream, they just look differently. They just look different. Another example of physical change, just wanted to show you guys. We have these different colored papers, right? So if you unfold this paper, it will look different, but we still know that it's still the same paper, right? 5 points if you got it correctly, okay? All right, ready for the final question? Give an example of a mixture that's separate if they just sit for a long time. So give me an example of something that will separate if you just leave it on the counter for a while. 10-point question. No cheating. The answer, well, there are a lot of possible answers. Again, I'm going to give you some examples, and if you said another answer that you know for sure that is the correct answer, then you should give yourself 10 points. I thought of shaving cream, orange juice, hairspray, liquid medicine, oil and vinegar salad dressing. That is like balsamic olive oil dressing. There's a lot of different answers, and we have a pretty picture of a mixture that separates right over here. 10 points if you're correct. Now, ladies and gentlemen, is the fun time. You have to add up your points. So pause this video, add up your points, and play it again. Okay, let's see what our prizes are. If you got 20 to 30 points, give yourself a huge hug, okay? If you got 10 through 19 points, give yourself a high five. If you got 0 to 9 points, give yourself a nice pat on the back. Just say good job. You did your best. And review yesterday's video. That's your prize. Okay. Now we can move on to our lesson. So just a quick review, we got here separating substances in mixtures. So remember that a mixture, it's not held together chemically. So you can remove each ingredient. For example, here you can, if you like the candies, you can remove all the candies and put it in one pile. If you like the pretzels, you can take out all the pretzels and put it in one pile, etc. Okay? Liquids with different density. Just a reminder, let me make this a little bigger for you. If an object is very heavy and compact, it means it has very high density. So, if you look at a substance such as this orange juice over here, when each of the liquids in a mixture has a different density, kind of like weight, then the mixture might separate. So if we leave this orange juice on this desk and the substance is separate, as you can see here, which one do you think will sink to the bottom? Well, I know you can already see the picture, but if you think about it, would the pulp sink to the bottom? Would that be heavier? Or would the liquid, like the water, sugar water, sink to the bottom? Which one do you think will be on the bottom? So of course, orange pulp is a lot heavier. So it's more dense, so it will actually sink to the bottom. Okay. Another example, we have salad dressing, right? So we got this oil and vinegar salad dressing. If we just left this on our desk and it's separated, which one do you think will go on the bottom and which one do you think will rise to the top? So remember, the more dense the liquid is, that one is the one that's going to go on the bottom. So oil, olive oil or any oil versus vinegar, what is denser? Vinegar is actually more dense, so it will go on the bottom and the oil will rise up. Next we have salt and sand. So this is not liquid, this is more of the solid section. So if we mixed salt and sand together, and I told you that your homework was to separate all the salt and all the sand, first thing you'll do is probably say, no, that is the worst homework ever. But if we had to separate the salt and sand, how will we do that? I think I can tell that you already know the answer, right? Because you're smart. Yes, that's right. We know that salt dissolves in water. If you put salt in water, it'll disappear. It will not disappear, but it will dissolve. If you put sand in water, it will not dissolve. So if you want to separate it, you just gotta put water in the mixture, and then the salt will dissolve and the sand will sink to the bottom. Okay, yes, that's correct. But then how do we separate the salt and the water? Talk to me. Yeah, so if you boil it, we know that the water will turn into gas, right? It will evaporate and the salt will be left over. So there are lots of different ways to separate mixtures, and this is what we were talking about today so far. The last thing is just two types of mixtures that I wanted to tell you guys about. You'll need to know this to finish your workbook. Just two more slides. Well, four. Homogeneous mixtures. Okay, basically they're mixtures where everything is blended evenly. For example, we got puree, coffee, milkshake, chocolate, cold tomato soup, orange juice. They're blended so evenly that you can't really pick out the original ingredients anymore. So that's a homogeneous mixture. Everything is just blended so evenly. Okay? Heterogeneous mixtures, that's the opposite. It's not blended perfectly. So as you can see, this fruit here, it's not mixed completely, right? It's not a smoothie yet. So we can pick out the strawberries, we can pick out the mangoes, the grapes, the blueberries. Other examples: salad, fruit salad, paella, which is like a Spanish dish, milk and cereal, and chickpeas. You can individually separate those ingredients. So again, homogeneous, everything is mixed very thoroughly. Heterogeneous, it's not really mixed thoroughly. Okay, so those are our those are our examples of mixture. And what I'm actually going to do is stop here, and in the second video we will read the textbook and do the workbook. Okay, thank you so much for being flexible, and thank you for joining, and I will see you in the next video.